Good afternoon and welcome back to the workbench. So today I want to do a video on valve amplifiers, or specifically this little circuit that I've been playing around with, that I built yesterday and I've been testing out. And building a valve amplifier, just like a stereo one, hi-fi sort of thing, is something I've always wanted to do, and I've finally decided to get around and do that. So to start with, I bought a couple of little speaker transformers from JCar. I did a previous video on these about how to find the center tap on a multi-tap transformer, where I spoke about this sort of thing. Anyway, this is not exactly a valve output transformer for a speaker. It's like a 100 volt PA line transformer, so it's designed for audio distribution networks or systems, whatever, like in a shopping mall where you want to drive a whole lot of speakers from one amplifier, and it's just more efficient to use a high voltage than to have an actual direct output, because you'd lose too much power with all the wiring. Same reason that the power lines out on the road are tens of kilovolts. It's just much better efficiency to drive things like that at a higher voltage. You get much less losses in the wiring, so it's a better thing to do. If you ran 120 volts or 240 volts, whatever, directly on those wires, you'd lose so much power with the resistance of the wires. You'd have to waste a whole lot of energy, and also you'd have to supply so much current because of the lower voltage that the wires would have to be massive. So it's just doesn't make any sense. So anyway, similar principle, not as on such a big scale, but yeah, that's why they have these transformers. And anyway, these transformers are fairly well suited to making little valve amplifiers with. This is a 5 watt one, I bought from JCar. It's the only one they sell, but other companies like Ultronics in Australia and I guess other countries do sell higher wattage ones. Like I think there's a 10, 15, 20 watt versions you can buy there. I thought I'd start with these because it's the easiest one to get and it's fairly cheap, and I didn't really want to muck around too much with trying to build some sort of high-powered thing to start off with. I just wanted to make something as basic as possible, and I wanted to use just some parts that I had lying around. So for example, these capacitors here, and these box of valves here I got. Well, actually I found them on the side of the road a while back. So they've just been chucked out. I have no idea what the condition of most of them are in. Some of them are completely dead, like this one here. You can see the getter on top there, which should be shiny silver, has turned white, so you can tell this valve was cracked somewhere and the air's got in and done that. So if you ever see a valve like this, it's broken straight away. Although not all of them have the getter on top. For example, this one here, it's actually on the side there. You can probably see this kind of sort of black silvery coating there. It's not so obvious because most of it's covered by this base, but it's not on top, it's actually on the side. So just because you don't see one on top, like say this one where it's on top there, sometimes it's on the side or at the bottom or whatever. So if it doesn't mean that this one's faulty, this one's still perfectly fine. But if it's got this white like this, it's definitely bad. Of course, valves can fail in other ways too, like the heaters can burn out. You can get shorts between different electrodes internally in that, just due to old age or being physically dropped or something, or manufacturing error. So just because it looks good doesn't mean it is good. It could be just worn out as well, like low emission, that sort of thing. So yeah, the fact that I found these on the side of the road doesn't really tell you much. And of course, none of these look brand new at all. They all look like they've been used to some extent. Most of them aren't really useful for audio. Like this one here, for example, is an EHT rectifier for a TV set, so that normally feeds you like 15, 20 kilovolts, an EY86. So that's not much use. But some of these, got like triodes or pentodes or that sort of thing. Some of these are useful for audio, and also I think I had about 30 AU7s, 12 AU7s. Or similar, like 12AX7, and also ECC82 and ECC83, which I think are like, those are like is it like the UK and US equivalent of the same thing? I think. Like I think the 12AU7 is practically identical to the ECC82, which is the one I've got here actually. That's an ECC82. But yeah, anyway, so let's talk about the circuit. So I've wired this up. Actually, I'll put these away so you can see this better. Yeah, so I've made this little basic circuit here. I've got, like I said, the ECC82 here. This is a twin triode valve. Same as the 12AU7. It's very popular, I think. Still, they still make them. Like in China, Russia, I think you can buy brand new ones. Don't know if like there's any brand new American ones or British ones, whatever. You can get any more, but yeah, you can definitely buy them new. This is obviously second hand. So yeah, I've just made this little basic circuit here. I was looking at a website, I think it's called valvewizard.co.uk or .com, and I'll put a link in anyway. I was reading some of the stuff on that, and it came up with like the basic circuit. It's probably like the most basic thing I could think of, and like I said, because these tubes are obviously second hand, I don't know what the condition is, and like I've just got these random parts here, high voltage capacitors and that, so I thought I'd just make up the simplest thing I could that would, at least let me test this valve and see if it was working, and would allow me to swap out all the other ones, obviously, that are comparable and test them as well. And I didn't want to go too much effort in case it didn't work, that sort of thing, so I just made the basic thing as possible. So I'm using both sides of this, or both triodes, whatever, in this tube. First one is the like a preamplifier stage, I guess. It just takes the input directly in. This is obviously mono, obviously one channel. There's only one there. You could make it stereo if you use both halves. You wouldn't get as much gain, obviously. So the first stage is like an amplifier preamp that just drives the second stage, which then drives this output transformer here. And that drives a speaker, which is down here underneath the table, which I can't really fit on the bench. It's quite big, so that wouldn't really make any sense. But yeah, I've got a benchtop power supply here, set to 12.6 volts to drive the filament. With the 12AU7, you've got two filaments actually for each triode, and you can drive either them in parallel at 6.3 volts, or you can wire them in series at 12.6, which is what I've done here. I've got the high voltage, it's not that high, it's 130 volts, off this voltage multiplier here, off this transformer, so it's a bit dodgy, and there's a little bit of ripple because it's not filtered properly. This capacitor is only 10 microfarads, so it's not that great, but it works. It gives me about 120 volts when it's running, so yeah, it's good enough for testing. This transformer, like I said, is 100 volts rated, so I didn't really want to go too far above that, just in case. Like, I'm not sure in terms of the capability of these things, what they're actually rated to. I mean, it says 100 volts on it. I assume the insulation resistance, insulation breakdown voltage of like between the windings and that is higher. But there's no actual specifications on it, so I'm gonna probably have to do some research and ask around online and that. See if I can find out more information about these and what sort of the maximum voltage you can get out of them. But as it is, I mean, it seems to work, so yeah, I'm just leaving it at this, and also yeah, it just makes things easier, and these capacitors here are only like 160 volt rated, so yeah, makes more sense just to keep it at like 100 volts or so, I think, for now. But yeah, so this is just a really simple setup. I just used sort of some basic sort of example circuits, like I said in the documents I was reading on that Valve Wizard website, and yeah, it seems to work. So I'll power it up, and I'm going to record the audio with this. So hopefully you'll actually be able to hear something half decent of what it sounds like. So yeah, so I got this at current limited, so 250 milliamps. So I'll turn the heater on here. Just wait for this to warm up. I got this current limited because I don't want this to heat up too fast. If I turn the current limiting off, it gets pretty bright when you first turn it on, so that's not good for it. I I think because I'm running this off a solid state power supply, and of course normally you'd be running this straight off a transformer, and probably, you know, the impedance of the winding would be higher and you wouldn't get that issue. So we don't want to do that, so that's why I've got this here. So now it's warmed up. Stop current limiting, so it's running about 200 milliamps I think, because the filaments are in series. So I'll turn my high voltage on, and I've got this on here so I can see how high that is. So I don't poke it while it's still charged. All these capacitors are all still charged up. So if I plug this in here, I get about 120 volts. You can see, and we can see this trace. So actually the oscilloscope here, I don't know how obvious this is on the camera, but this is the input trace here from the output of the sound card from the computer, and then this is my output from the well, it's actually from the output of the first triode, I think. How do I connect it? Or was it? No, hang on, it is the... Sorry, yeah, it's the second one. I was looking at the second one first. Anyway, yeah. There's the output there, so that's connected by... so that's showing what's going to the transformer. There's a little bit of ripple here, because like I said, the filtering on this is not that great, but you can't really hear it that much. It's not too bad. Obviously, I'd make the power supply better, too, if I was actually going to use this. But yeah... so that's all powered up, ready to go. So if I actually play some music, that's more of that YouTube royalty-free stuff. So like I said, this is the most minimal sort of circuit I could think of. There's no cathode bypass capacitors on this. I don't know if the gain is like as high as it could be either. I set it to sort of you know, I set fairly like moderate sort of values in terms of resistors and that, so I didn't want to go too high to start with. So I sort of just, you know, don't want to overdrive anything. I want to get a good idea of how it sort of works with pretty low sort of output. But it is fairly loud actually, considering this is probably running like, I think I calculated it, the output is probably about 700 milliwatts. Not 700 watts, obviously. Yeah, it's about 0.7 watts, I think, or thereabouts. Probably maximum power it's going to put out. But in terms of like comfortable listening, I think that's pretty good for most cases. So actually, I'll turn this on and try and yeah, hang on, I'll just pause that. Go set this up. Okay, record this. So yeah, I'll try to do a sort of like volume comparison between my voice, so you know, like there's a typical speaking volume, and then I've got the volume this is outputting, and you should be able to hear, you know, get some general idea of what that's like. So actually, so the output from the sound card is at maximum volume, which is typical. And then this obviously is fixed gain, there's no volume control on that, so that's just running at the maximum that it's set up for. And that seems to be actually pretty good listening volume. So if I just start playing this, angle this down here. And you can see you've got the input trace here, and yeah, so it's definitely amplifying. It's actually not bad. It's not bad at all, I think. I'm actually quite surprised at how good it is, to be honest. Considering how big, how simple the circuit is. So there's that kind of thing. I'll try like a more sort of instrumental, maybe. I mean, less like synthy sort of stuff. You can see the voltage jumping around because obviously the ripple on this isn't really great. But yeah, I mean, I think it's hilarious, actually, just how simple the circuit is. It's like one valve, 5 resistors, 2 capacitors, a couple of transformers. Yeah, I mean, okay, more than power supply in that, but I mean, it sounds good. It sounds pretty good, and I don't think it's funny. Like 10 components, and you get a pretty decent level of power, and it sounds really nice. I mean, I'm surprised. I don't know what I was expecting. I was expecting it to sound a lot worse. Maybe like just wouldn't be enough power and it would distort trying to drive this thing or something. But I mean, obviously this is at maximum volume, and you're not going to get any more power out of this. So, you know, but for just general listening, it's nice. It's a perfectly comfortable listening volume, and it sounds good. There's like, I mean, there's probably distortion given that it's like it's a tube and that's the whole point, but in terms of like, there's no obvious distortion that sounds bad. There's nothing that sounds, you know, it's just nice, and it's such a simple circuit. I mean, to get something with that low component count, you have to use the solid state thing. I guess you'd have to use like a, yeah, like a integrated circuit, like a, think of something, but you know, maybe like a TDA 2007 or a LM386 or you know whatever. What is it? What is the one that people use in the game clone amps? Like the LM1883 or something. That's probably completely wrong, but you know, something like that. I mean, that's a pretty simple circuit, isn't it? But you know, you've just got your little chip and then like a couple of capacitors, a couple of resistors and that. So it's probably about, component count will be the same as this, but yeah, in terms of like complexity, I mean, that whole amplifier chip is going to be how many components inside that. So I like it. It's hilariously simple, and I think it's the basis of a nice little computer speaker sort of like amplifier thing. If I build 2 of these, I might have to tweak it a bit. Like I said, I want to try and see if I can get a bit more power out of it. Maybe I'd add like, I have to turn this off, can't I? I guess what I would do maybe is, you know, add like the cathode bypass capacitors. Maybe tweak the resistor values to try and get a bit more gain out of it, see if I can get a bit more power. But yeah, I mean, I think it's perfectly reasonable to say you could make a fairly decent little like computer speaker stereo amplifier with just 2 of these valves and a bunch of components and 2 of these transformers. I mean, even this like really really crappy voltage multiplier for the 120 volts is I mean, I don't think I'd use that. Well, I mean, I might if I did build one of these. Although I'm getting a fair bit of ripple. I think this would be about, actually that's 2 volt. Well, I have this on 20, so it's about, yeah, I think there's about 5 volts peak to peak ripple on there, which I suppose is not bad considering it's like 120 volts, but yeah, I would want to regulate that a bit better, I think, if I was going to use that. Or maybe just use 2 back-to-back transformers, so although that would give me 250 volts, be a bit high. I don't know if I want to do that again, like I said, because these are only designed for 100-volt systems, so I don't know if I want to go too high for that. But anyway, yeah, it's pretty cool. I'm impressed. I'm impressed at how good it sounds just for being such a simple thing, and I like it. I know one of you asked about trying to make a headphone amplifier with valves, and I know nothing about that. I'm not sure. I mean, obviously, this speaker transformer is designed for 8-ohm speakers, and that's what I'm driving. And I think headphones are going to typically be like 32 ohms at least, maybe even higher, maybe 64, maybe higher than that. I know some go to like 600 ohms. So I don't know in terms of that what that would cause, whether you just get less power or more power, whether you get distortion or not. You probably have to adjust some of the values. I mean, could you use a 64 ohm pair of headphones directly with a transformer designed for 8-ohm speakers? I'm not sure. I'm not sure what that would do. I may try it out and just see how it goes, but I mean, yeah, I think some of the designs I've seen online for driving headphones, they've got like the output stage is actually a JFET or a MOSFET or something, because that's better at driving the headphones than trying to find a transformer that's designed to match that actual impedance. But hey, I mean, you may be able to run it sort of mismatched, and you may just get less volume out of it. I don't know. But yeah, something I'd have to play around with if I was going to try that. I may do it, see what it's like. But yeah, basically the upshot of this is I'm actually really happy with how this has turned out, and I'm quite impressed. And after, like I said, tweaking this a bit and getting a better power supply for it, I think I'll build 2 of them. I might even see maybe if I can use 3 valves. Maybe I could use like one. I could use one half of each of another one of these, and have like a third amplifier stage. So I could have like a preamp, 2 preamp sort of stages, and then the output stage. So you've got like 3 triodes per channel. Well, yeah. So that's it with 3 tubes. So yeah, and then I'll try and find a transformer that has the appropriate voltage winding, so I can drive like I think the idea would be to drive like the filament off one transformer winding and then multiply from another one to get the higher voltage. But yeah, I mean that works. It works really nicely. I know I said that about 5 times, 10 times now, but I mean I am actually quite surprised. Unless I'm completely overlooking something and there's something horribly flawed with this design, but I don't know. I mean, most of the tube amp schematics I've seen are actually really simple, so maybe it's just the way they are. But yeah, I'm really impressed with that, and I really like it. So I'm definitely going to be continuing this. And yeah, I mean, I would have liked to get maybe some more power with like a better tube or something, but like I said, the ones I've got are just random ones I picked off the side of the road, like literally off the side of the road. I don't really have like any sort of decent sort of output style valves that, you know, I've only got like 1 each of them, and of like any particular number there, and the rest of it like 30 12AU7. So basically the idea was like I want to make something with primarily using these ones here if I can, and I think it looks like I can. So there we go. I guess it is quite easy to build an amplifier using valves, and I'm quite enjoying this. Obviously you have to take care that you got high voltage here, and obviously these things run, you know, hot, like as in temperature. You don't want to burn yourself on it. But yeah, it's quite fun. I won't put a schematic on it right at the moment because, like I said, it's not really finished. So I'll do that later when I do some more work on it. But yeah, for now it's quite fun indeed. So yeah, I'll hopefully do some more on this later and see how it goes. And but anyway, for now I'll see you next time.